Hello, everyone. I'm Lee Hong Mei from number 3 Vocational Technical School of Nanning. Welcome to this mini-lecture. In the previous lesson, we have studied the OSI reference model. In this session, we will learn about the TCP or IP reference model. This mini-lecture is divided into two main parts. 1. The TCP or IP architecture. 2. The differences between TCP or IP and the OSI model. The teaching objectives of this mini-lecture are as follows. 1. To understand the TCP or IP architecture. 2. To grasp the concepts and functions of the network interface layer, network layer, transport layer, and application layer. 3. To comprehend the differences between TCP or IP and the OSI model. Firstly, let's briefly review the origin of the TCP or IP model. The TCP or IP reference model is the foundational model used by ARPANET and the Internet. It adopts a layered structure corresponding to the OSI model, and can be divided into 4 layers: network interface layer, transport layer, and application layer. Now, taking the example of HTTP application data transmission, at the application layer, HTTP data is the actual data to be transmitted. This HTTP data is passed down to the transport layer, where it becomes a protocol data unit, PDU, with a TCP header, known as a segment. The segment is then passed down to the Internet layer, where an IP header is added, forming a protocol data unit, PDU, at the network layer, known as a packet. The packet is then passed down to the data link layer, where an Ethernet header is added, forming a protocol data unit, PDU, known as a frame. Finally, the frame is transmitted at the physical layer as electrical signals, zeros and ones, through the physical medium. Through this process, we can see that from the HTTP data at the application layer to its transmission over the network, multiple layers of protocols and mechanisms are involved, ensuring reliable data transmission and correct presentation. This completes the overview of the HTTP application data transmission process. Next, let's explore the characteristics of TCP or IP. First, it employs open protocol standards, promoting rapid technological development and innovation. Second, it utilizes a unified network addressing scheme, ensuring global connectivity. Third, it is independent of specific network hardware, allowing for flexible network design. Fourth, standardized high-level protocols ensure compatibility and interoperability between different applications. These characteristics together give TCP or IP model robust vitality and widespread application. The network interface layer, also known as the data link layer, forms the foundation of the entire model. Corresponding to OSI's data link and physical layers, it manages data exchange between devices and networks, as well as within the same device and its network. It receives datagrams from the IP layer above, sends them out over the network, or receives and processes physical frames from the network, extracting IP datagrams to pass up to the IP layer. Imagine when you send a message over the Internet, it first passes through this layer before being sent out into the network. The network layer, also known as the IP layer or Internet layer, is crucial for managing data exchange between different devices and enabling communication between adjacent computers. It corresponds to OSI's network layer. At this layer, data is encapsulated into IP packets and transmitted across the network using IP addresses. Key protocols of the network layer include IP, ICMP, ARP, and IRP, which collectively ensure proper data flow across the network. The Internet layer primarily encompasses 4 protocols. 1. Internet Protocol, IP, uses IP addresses to identify sending and receiving ends, facilitating end-to-end datagram delivery. 2. Internet Control Message Protocol, ICMP, handles routing and assists in the control mechanism for message transmission at the IP layer, providing error and information reporting. 3. Address Resolution Protocol, ARP, translates network layer addresses into data link layer addresses. 4. Reverse Address Resolution Protocol, IRP, translates data link layer addresses into network layer addresses. The transport layer is responsible for providing reliable end-to-end data transmission between two process entities. It corresponds to the transport layer of the OSI model. At the transport layer, there are two significant protocols, TCP and UDP. 1. TCP provides a reliable, connection-oriented data transmission service between hosts. It manages issues related to flow control to prevent fast senders from overwhelming slow receivers. 2. UDP is an unreliable, connectionless transport protocol used in situations where reliability is not critical but low latency is required, such as in transmitting voice and video data. It supports one-to-many or many-to-many data transmissions between hosts, such as broadcasting or multicasting. Finally, let's understand the application layer, the highest layer of the TCP or IP model, which provides protocols for various applications such as HTTP, FTP, SMTP, and more. Corresponding to the transport layer of the OSI model, it ensures reliable end-to-end data transmission between two process entities. This layer directly interacts with users, offering a rich set of network application services. Lastly, let's discuss the differences between the TCP or IP and OSI models. While both models employ the concept of layered architecture, they differ significantly in terms of layer hierarchy, naming conventions, and functional details. For instance, the OSI model, defined by ISO, consists of 7 layers from physical layer to application layer, primarily used for teaching and theoretical analysis, with its defined protocols not widely adopted in practical applications. In contrast, the TCP or IP model is commonly considered a 4-layer structure, foundational to the Internet, with core protocols like IP, TCP, and UDP widely applied in real-world network communication. The OSI model's layer divisions are more strict and abstract, whereas the TCP or IP model emphasizes practical protocol implementation and application, offering greater flexibility. Despite widespread educational use of the OSI model, the TCP or IP model is more prevalent in technical practice due to its close association with the Internet. Now, let's summarize what we've covered in this lesson. We've learned about the TCP or IP architecture, the HTTP application data transmission process, concepts and functions of the network interface layer, network layer, transport layer, and application layer, as well as the differences between TCP or IP and OSI models. Finally, to reinforce what you have learned, I have prepared some exercises for you to complete after class. I hope each of you will diligently complete them and internalize what you have learned. This concludes the mini lecture today. Thank you, everyone.